let us play a game. I have thought of a 2-digit number and you need to tell me what is the number that I have thought of. Well, there are so many possible values of 2-digit numbers and you may feel that it is quite unfair to you because there are 90 2-digit numbers and you need to tell me which is the number that I have thought of. So among these 90 numbers, you need to identify the one number which I have thought of. So that is obviously not possible. So let me simplify it a bit for you. I'll give you a hint. The sum of the digits of the number which I have thought of is 9. So now you can consider all the 2-digit numbers, add the tens digit and the units digit of each number and check which are the numbers which give you the sum of the digits as 9. So, if you take 18 as the number, the tens digit is 1, units digit is 8, and 1 plus 8 is equal to 9. So, 18 could be a number. If you consider 90, tens digit is 9, units digit is 0. So, the sum of the digits is 9. So, 90 could be a number. So, calculating the sum of the digits for 90 numbers in this manner, you get these as the possible values. So, these are the 9 numbers, that is the 9 2-digit numbers which give 9 as the sum of the digits. Calculating the sum of the digits for 90 2-digit numbers is a tedious task. And what is the point of studying mathematics if we have to calculate everything manually? Well, is there any way in which you can represent this hint mathematically? Well, yes, there is. If you consider the tens digit of the number to be x and the units digit of the number to be y, then the sum of the digits will be x plus y. So tens digit is x, units digit is y, sum of the digits is x plus y. So we should have x plus y is equal to 9. And this essentially is the hint which I have given you. X plus y is equal to 9. Now, x and y are the digits of a number. So we know that digits are integers between 0 to 9. So the value of x and y would be 0, 1, 2, 3 and going on till 9. So if x is 1, then this will be 1 plus y is equal to 9. From this, we get value of y as 8. So if x is 1, y will be 8. Similarly, if x is 2, y will be 7. So going on till 9, we get the different possible combinations for x and y. And corresponding to each combination, we have a number. So when the tens digit is 1, the units digit has to be 8. And the corresponding number is 18. When the tens digit is 2, the units digit has to be 7. And the corresponding number is 27. Well, you may ask me, why haven't I taken the value of 0 in place of x? If we take x as 0, the tens digit will be 0. But we are considering only 2-digit numbers. So the tens digit of a 2-digit number cannot be 0. So we ignore 0. So we take x from 1 to 9 and find the corresponding value of y and get these as the possible combinations. Now look at this. X plus y is equal to 9. You will observe that it is an equation because it states that this is equal to this. So x plus y is equal to 9 is an equation. Also, there are two variables, x and y. So it is an equation in two variables. Now the power of both the variables is 1. It is x to the power 1, y to the power 1. So this is a linear equation in two variables. So an equation which has two variables and in which the power of both the variables is 1 is a linear equation in two variables. And this is the general form of a linear equation in two variables. Ax plus by plus c is equal to 0. Here a, b and c are the constants and x and y are the variables. Note that a and b cannot be 0. Now let us compare it to x plus y is equal to 9, which was our equation. So we can write it as x plus y minus 9 equal to 0. Now a is the coefficient of x, so a is equal to 1. B is the coefficient of y, so b is equal to 1. And c is the constant term, so c is negative 9. So this is a linear equation in two variables. Now using this linear equation in two variables, we have got these possible values. But observe that we have not got a single value for the number. We still have 9 possible numbers. So a linear equation in two variables does not give us a unique solution. As in this case, we can clearly see that this linear equation in two variables does not give us a single number. It gives us 9 numbers. So a linear equation in two variables does not give us a unique solution. We can change the value of x, and for each value of x, the value of y will keep on changing accordingly. So we can have many possible solutions for x and y which satisfy the linear equation in two variables. So a linear equation in two variables does not have a unique solution. Now let us come back to our game again. So from 90 numbers, you have got these 9 numbers. But you still have a long way to go because you need to tell me just one number. So let me help you once again. I'll give you one more hint. If the digits are reversed, the new number is 45 more than the original number. What was the original number? The original number is a number in which the tens digit is x and the units digit is y. But be careful. This is not x into y. So this means that the tens digit of the number is x and the units digit of the number is y. This is not x into y. If we have a number 18, this does not mean 1 into 8. It says tens digit of the number is 1 and the units digit is 8. Now we can write 18 as 1 into 10 plus 8 into 1. That is the digit, which is the tens digit, is multiplied by 10. Units digit is multiplied by 1 and both are added. So we can do a similar thing for this case. So the tens digit is x. So we write x into 10 plus units digit is y into 1. So this gives us 10x plus y. So this is our number. 10x plus y is the number which I have thought of. So this is the number. Now, can you answer this question? If the number is reversed, that is, the tens digit of the number is y and the units digit is x, the reversed number is. Now, if the tens digit is y and the units digit is x, the number can be written as y into 10 plus x into 1. Y into 10 is 10y and x into 1 is x. So this is 10y plus x. So if the digits are reversed, we get the number 10y plus x. So if the original number is 10x plus y, the new number, that is the number formed by reversing the digits of this number, is 10y plus x. Now the hint says that the new number is 45 more than the original number. So 10y plus x minus 10x plus y is equal to 45, because the new number is 45 more than the original number. This is what we have. Now we can simplify this. So let us simplify this. 10y plus x minus 10x minus y is equal to 45. 10y minus y gives you 9y. X minus 10x gives minus 9x. That is equal to 45. Now 9y minus 9x, we can take 9 common. So 9 into y minus x is equal to 45. Now we can transpose this 9 to the right hand side. So we get y minus x is equal to 45 by 9, that is 5. So we get y minus x is equal to 5. So this is what you get from my second hint. So this is what you have from the second hint. Even this is a linear equation in two variables. So you have got these two linear equations in two variables. From the first equation, you had these as the possible values. So these were the possible values of x and y. Now you just need to check which values of x and y satisfy this equation as well. So if y is 8 and x is 1, 8 minus 1 gives us 7. In this case, y is 7 and x is 2. 7 minus 2 gives us 5. So similarly, we calculate for all the values. And we see that there is only one value, that is this value, for which both the equations are satisfied. So if x is equal to 2, and y is equal to 7, then both the equations are satisfied. So my number is 27. So now you can tell me for sure that the number which I have thought is 27. You can check. 27 is a two-digit number. The sum of the digits is 2 plus 7, which is equal to 9. The number formed by reversing the digits is 72. 72 minus 27 is equal to 45. So the second hint is satisfied as well. So 27 is the required number. So if we have two linear equations in two variables, we get a unique solution. So when you have two variables, you require at least two equations to get a unique solution. Now, these are two linear equations in two variables. We call them simultaneous linear equations, or a pair of linear equations, or a system of linear equations. Now, why do we call them simultaneous linear equations? You may recall that when we had just one equation, you were not able to get a unique solution. You got 9 possible values. But when you had two equations, you obtained a unique solution. So since we have two variables, you require two equations to solve them. And the solution should be such that it should satisfy both these equations simultaneously. Hence, these equations are called simultaneous linear equations, or you may call it pair of linear equations or system of linear equations. So let us see the general form of a pair of linear equations in two variables. a1x plus b1y plus c1 equal to 0. This is the first equation. a2x plus b2y plus c2 equal to 0. This is the second equation. So these are two equations, a1, b1, c1, a2, b2, c2. These are all constants. a1 and b1 both cannot be 0. Either of them, that is any one of them could be 0, but both cannot be 0. Similarly, a2 and b2 both cannot be 0. X and y are the variables. Now, important point to note is the variables should be the same in both the equations. So if you have x and y here, you should have x and y here. So this is the general form of a pair of linear equations in two variables. Now can you tell me, does the following represent a pair of linear equations in two variables? Well, this is a linear equation in two variables. So this is a linear equation in two variables, x and y. Even this is a linear equation in two variables. So it is a linear equation in two variables, x and z. But the variables in the two equations are not the same. X is common to the equations, but in this case we have y, whereas in this case we have z. So these two do not represent a pair of linear equations in two variables because you do not have the same two variables. Here you have x and y, here you have x and z. So actually in this pair there are three variables, x, y and z.